All right, so I've started the recording of this session. Sorry for that. I have a bad cold today. Anyway, so let me just quickly introduce myself, and then we can actually get started with the discussion, right? Hi everyone. This is Amit here, and talk just to talk a little about myself. Have been in this industry for about 6.5 to 7 years now, and been primarily working in the data science space right from the start. I've worked for three MNCs for now, and have worked across multiple industries ranging from life sciences, healthcare, to retail to financial services. So that was a little, that was a quick introduction about me, and I'm pretty sure you must have interacted with Siddhant some way or the other. So both Siddhant and we have we collaborated together to run these online sessions and talk about how data science has evolved from A to Z, right? So right now, I mean, there is definitely a buzz going around in the market, and people have been talking about how data science is becoming popular, day by day. So there are various factors when you have to consider when you start talking about data science. First one being, what is the market trend? I mean, when I say market trend, I'm talking about how the business is flowing, right? Because frankly speaking, when I got into the space, there were hardly clients and vendors who were interested in investing in data science, right? Because there was no future, there was no scope. This is I'm talking about 7.5 years back. But today, if you see every FSI, I mean, financial services client or consumer or retail or a life science healthcare client wants to invest in data science so as to make sure that its business is growing and it's competing with the market, right? So the first point is the market trend, right? Because that's what gets you business. Second is your job up. Once you start talking about business, it starts getting linked to job opportunities. So the more the volume of the business, the growth is exponential, the more are opportunities, for jobs for data scientists in the market. When you say there is a buzz, you see the market trend, there are multiple job opportunities. And again, not to mention, these job opportunities are on a very high scale, right? When I say high scale, I'm talking about the pay bands or pay scale, which are at an extremely high level. Because personally, I have seen how people have jumped from 0 to 10, 10 to 20, 20 to 100, so this is something which is very promising, and I can guarantee you, or I can assure you, that's not going to go away easily in the next 20, 25 years, because this is something which is evolving and it's learning every day, right? Just like our models which you build, there is a continuous learning curve which is involved as part of this technology and this approach towards mathematics and statistics, right? So talking about another important factor is the applicability across industries. So there were certain technologies which were limited to financial services. There were certain technologies limited to the retail part of it. But with this data science, every client, I mean, every individual organization across the spectrum of industries is trying to get into this domain and make sure that they explore it to its full potential so that they have a growth in their business, right? Because ultimately, they deal with their customers. For example, there's a retail client. I mean, it's a small store based out of a small city. Even I mean, the store owner would be really interested in understanding the footfall, the particular type of products which are being sold, what are the type of products which are added to the cart but are later discarded at the billing counter. So multiple factors come into place. I mean, we call this as features. So right now, I don't want to get into the discussion where I talk about what exactly the feature is, but just to set the context here, I mean, you have to consider multiple pointers, if I may call it in that way, to kind of go ahead and create your model which will do predictions for you. So I don't want to throw big words at this point of time. Let's just quickly get down to the deck which we have, and then start talking about uh, you know the data science part of it for this session. So big questions first. I mean, let's just talk about why data science. I mean, there are a few questions which you see up on the screen right now, and we'll go on to talk about each of these questions in detail as to why do we have to do data science. I mean, where does the data come from? How to define data science? I mean, that's the most elementary question or the fundamental question which every data scientist should be able to answer is what is data science? How is it different from business intelligence, which few organizations and few companies were doing for the past 20-25 years, because the whole data science buzz has been in the market for the past 10 years. Then what were those companies doing in the past 20 years? What is that special which has evolved in those 10 years, which is being called as data science? Okay, so how do you do data science, right? Because this is something, as I mentioned earlier, this is something which is evolving, right? So if you're doing something today, it's fairly possible that it might not be possible the next day. So what is the approach you follow when you get into the data science field? And the last question said, I mean, who are data scientists? Are people who do all these mathematics and statistics? What makes them qualified to be what qualities do they have so that they can be called data scientists? So uh, before we actually move on to answer these questions, I'll just quickly give you a point here, saying that there are a lot of people who actually approached us and told us like, look, from what I understand from online websites and blogs, the data science is all about mathematics. I mean, to be very frank, I would not deny that. It's extremely important to know the concepts of mathematics, primarily from statistics and probability domain, but it's not a rocket science that you will not understand it, because there are few folks coming in from background, not I mean backgrounds not pointing to technology. I mean, when I say technology, I'm talking about engineering, but there are few folks from commerce and there are few folks from arts who are great data scientists today. So the fact that people come from diverse backgrounds and do not have the expertise in mathematical concepts have still excelled in data science guarantees you that you have to have an understanding of how the model is working in and how the model can be explained better and can be efficient enough. So there is certain amount of mathematics there, definitely not denying that, but it's not that it's just pure mathematics. You have to have that acumen, that analytical approach, that understanding towards your code, your model, so that you build a model which is efficient and accurate enough to make sure that the predictions are right. Okay, so if you can see my screen, there's this map of Mexico which appears on the screen, and you could see a geo heat map. So what a geo heat map is you basically divide your area into multiple geographies and then assign a color which is depicting the intensity of a particular prediction or a feature in that combined geography. So what you see up on the screen are multiple colors, ranging from green to red. Okay, so this is again the effect of a particular type of flu in various states of Mexico. Now this is a prediction model which was built on considering multiple data features, so as to come up with a prediction saying that, look, this particular state is in a critical area. Now when I say critical area, what I'm trying to say is the possibility of the possibility of flu spreading in that area was quite high. Okay, so this variation of color is again depicting the density or the probability from lower to higher or from higher to lower in terms of color variation of that particular state. Okay, so let's say for a green, I could understand, look, in that particular state the probability is really low, so my government schemes and my all my uh, initiatives towards getting rid of the flu for that particular year or for that particular range of year could be focusing on few states rather than the other ones. So that way it gives me an understanding of where should I put my resources. Okay, and that saves me money, that saves me time, that saves me resources. So these, I mean, you start building models which basically talk about, or uh, gives you the risks of spreading particular types of flu or virus in various geographies. So that was just one example of what data science is and why this excitement is coming up so fast in today's world. Now, talking about the IT industry, I mean, majority of us do come up from that industry. So there are various applications where you actually apply data science, right? I mean, if you talk about industry-wise, you can go ahead and give me an example saying that, look, I have a retail store, and for example, let's just not take a retail store example. Let's say I have an app of a particular store, and then I want to understand what is my consumer behavior. Now, when I say consumer behavior, these are two big jargons, right? But if you come down to the basic level, you would understand this is nothing but predicting how a consumer is going to react. When I say react, this basically means that what are the items I'm buying every month. Okay, what are the repetitions happening? What are the items which I add to my cart and then remove it? what are the items which I kind of add to my wish list and then I remove it. So that way I can understand, like, look, this particular consumer, this particular customer is interested in these range of articles. It could be t-shirts, it could be sweaters, it could be football. So that will help me understand what is the expectation, and then accordingly I can push all those articles, I push all those items on top of the screen so that he's more tempted to buy it, right? So I'm talking in from the business side of it. So that is again from the business industry point of it. Again, you have in the IT part of it, for example, you can see in the screen there's a recommender system called Netflix. So Netflix has this amazing algorithm where it kind of understands your movie preferences. So it's not that you saw a sports movie and then the next movie comes up as sport. It's a sports movie again, right? So there's something which is running behind and the back end which identifies that, look, you just saw a sports movie. So why don't I throw another sports movie, and that can make you glued to the system. So that's what a recommender system does. So that is what being used by Netflix, by Amazon Prime, and they try to shoot articles or movies which can be high in your preference order. Okay. So another example here is software log data Splunk. So this is something which I've been personally working on for the past 6 months, and this is an amazing data analytics prediction tool which runs through your software logs at runtime and makes sense out of garbage value. For example, you have a Java application. Now, every time your Java application is up and running on production, you have volumes of logs being created. 90% of them do not make sense because if you start looking into it, you would see garbage values. So that's where Splunk comes into the picture. So what Splunk does is it reads through your garbage value, starts making sense out of it in terms of it could tell you what are your most common issues, what are your high hitters, what are your pain areas, what are those areas where you can actually do some innovation, what are those areas which could be automated. These are the fundamental features of Splunk. But Splunk today has evolved itself into another tool which has machine learning capabilities as well. So with the help, or probably by leveraging Splunk's machine learning capabilities, you could probably deploy a regression or a classification model so as to predict the number of issues in a particular domain, or talk about the nature of issues in a particular domain. So these are evolving day by day, and these are small predictions which you can make out of data science applications. So going ahead, one second, guys. Okay. Now, let's just cover this quick slide and I'll take a pause before we open up a question. So where does the data come from? I mean, it's a very generic question. In today's world, it's pretty much simple to identify what are the sources of data. But the most interesting part of it is what you expect is just the 10% of it. For example, you have a Facebook app. If I tell you what a source of data, you could call out Facebook is something, YouTube is something, Twitter, it reads all my data. But do you know that Facebook has the ability to read what are the other things happening in your phone? What are the other applications you are accessing? So these points which you're not aware of constitute of the 90% of the data which is being accessed by a particular organization or by a particular application. So I mean, multiple places, right? It could be phone application. It could be going to a grocery store and then purchasing a few items. For example, let's say there is some section of a particular city where the sales of medicines has increased in the past 10 months. So that constitutes my data. I can go ahead and understand like what's going wrong. I mean, 10 days back it was absolutely fine. There were 10 medicines being sold, and now suddenly there is 40. Something has to be wrong. So this is where the whole data point comes in. Now, I mean, I would definitely like to go to the next slide, but just take a pause here and open up for questions if you might have any. Guys, if you have anything, please feel free, because I know I might be talking something which might not be making sense to you, but you will definitely get more understanding of it once we start getting into the further discussion. All right, I'll take that as an yes and go ahead with the further slides of it. Now, the most important question, as I just mentioned some time back, what is data science and how does it differ from the business intelligence which was done by a few other companies and organizations? Now, when you talk about data science, you have to talk about multiple aspects. First is machine learning. Second is visualization. And third is your data. Three important aspects of data science. When I say data, I'm talking about the data which we just discussed, the raw information or all the details from various applications, from various systems, from various offline avenues. So that is what constitutes my data. Second is machine learning. When I say machine learning, two simple words: you make a machine, it learns by itself. It depends on what type of machine you have to build, which will kind of apply to that situation. Third is the visualization. Visualization is when you have the data, you put your machine, it learns, it predicts, and then throws it out. But as a backend person who's working as a data scientist, he can actually give you prediction. But there is a certain way where there's a certain way in which you have to present it to the leadership, present it to the client, present it to the vendor. So that's where visualization comes into play. So there are various tools in the market, Tableau, ClickView. So you kind of use these tools so that the visualization and the output coming out of your model is in the most appropriate way possible. Okay, so if you kind of put it in a way, data science is basically an umbrella which has various spokes such as machine learning, visualization, data. Guys, if you're not, I would really appreciate if you can mute. So I think Yoganand was speaking with mic unmute. Anyway, sorry. So let's move ahead and talk about a little more about what is the difference between databases and data science. So since both these carry data, it's pretty confusing at times. But again, databases is at one point of time this was something which was physically existing, but in today's world we are moving everything to cloud, right? So the physical existence is no more there. So we move from physical existence to virtualization. But again, talking about the contrast between database and data science, the data science is a methodology which you apply, or the technique which you apply on data available in databases. It could be physical database, virtual, to make sense out of that data. Okay, so here we have various attributes that you kind of try to present a contrast in terms of, let's say, data volume. So let's say when you say data volume with databases, you have limited amount of data, right? There is definitely an unlimited amount of storage available, but when you talk about a particular application, there has to be a certain limit or a certain threshold till where you can put data, right? But data science, it's all open. You train your model, you test your model, you start making predictions out of it. Okay, so in the due course of the session, we'll definitely talk a little more about the exact contrast of it. But quick difference here between business intelligence and data science. So BI stands for business intelligence here. Now, like I mentioned, there were other organizations, such as SAP and Oracle, who had their own BI tools. So what were these companies doing, which was different from what data science is doing right now? So data science is not a group or this thing, right? It's an approach towards handling data. Now, the difference between BI and data science was fundamentally BI was a reactive approach. When I say a reactive approach, what I'm trying to say is an incident had occurred, something went wrong, I analyzed the data and then came up saying that, look, this is what went wrong. I am presenting an analysis of the past. Basically, I'm querying the past and giving you analysis and descriptions and inferences which are of events which have already occurred. But with data science, I do the same exercise, plus I predict the future. How do I do that? With the help of my model. My model learns my historical data, builds an understanding out of it, tries to evolve a pattern out of it, and then makes the exact prediction. Okay, so data science is past plus future, while BI is exclusively past and just inferences. Okay, now the next point is where we kind of talk about what is the difference between machine learning and data science. So I would take a pause here and open up for questions, and in the meanwhile, I'll ask Siddhant to take over the session and talk about the further topics. So if you have any questions, so both of us are here, feel free to pause us and interrupt the session. We can talk and answer all your questions, please. So if you don't have anything, Siddhant, probably you can go ahead and continue the session.
Yeah, thanks, Amit. Guys, can you hear me? Guys, can you hear me?
Yes, yes.
Yes, Siddhant.
Okay, so any doubts, any queries, please free to ask anything you want to know.
So don't wait for us to kind of take a pause and then open up for questions. If you at any point of time you feel like raising a flag or calling out something, feel free to do so, guys.
So, up to now, you just heard like, numerous times the word model and the data science and everything. But, it is time to see what exactly is the data science through the real-time application. Okay. So let's take, a paint board over here so that I can draw some pictures and I will tell you. So you know the supermarket, which is the the biggest supermarket in the world, guys?
Yes, it is.
Which is the biggest supermarket in the world?
Walmart.
Walmart.
Walmart. Yeah, Walmart. Okay. So let me go for the Walmart. So there is a pattern in the Walmart. Okay. So what exactly happens in the Walmart? Let me tell you. If you go and enter to a supermarket, you will see the things lined up. Like there is a bread one shelf, there is a biscuit another shelf, there will be a jam on other shelf. Is that they set up randomly or there will be a pattern? Is there any pattern?
Yeah, they will follow some patterns to set
Yeah,
up
what kind of pattern? How to decide that pattern? Can you answer it?
based on some categories. Yeah,
Categories, yes, based on some categories,
yes.
correct. So there is a a probabilistic measurement, or there is a model which can define me. So let me show you it quickly, a small program. Okay. So this is called appropriate algorithm, and the language which I have written is called R. Okay. So in R, I have just wrote 7 to 8 lines or probably 9 lines. Okay. So let me execute it. So I will tell you exactly what I did, and I'll show you the real-time application so that you can understand the data science pretty good. Okay. Yeah. So when I talk about the model, this is what is model is, right? So that program of 4 lines give me a model. So what exactly I did, I will tell you. Let's say I have a list of groceries which the people purchases during the time. Okay. So let me take that open the data set and I will show you the data. So there is a data set called groceries. Okay. So it says the person one came and he purchased something called citrus fruit, finished bread, margarine, and ready soups. The second person came and purchased tropical food, yogurt, and coffee. The third person came whole milk. The fourth person purchased, and so on and so on so forth. Right. So I have to read all the data sets over here. Let's say I have 1 million of the data or 10 million of the data. I think 1 million of the data, and I'll read each and every transaction, and I want to find that pattern which we talked about, where to put what, right? So here I got the thing. So some people purchase their cereals, some people purchase their curd. But if some people purchase their cereals and curd, they are probably high. They will going to purchase whole milk. So that what will happen? I'll place my cereals inside beside the curd and beside the whole milk, so that the people will come and purchase cereals and curd and whole milk, right? This is the pattern we were talking about. Let's say this is my red plus wine and the liquor. If someone is purchasing liquor and red plus wine, what is the highest probability measure? They are going to purchase something called bottled beer. So this is exactly the data science is. We find the pattern or behavior of the people which they are doing over the time, and we are going to forecast or predict the future outcome of that particular people. Can you give me an example of same criteria? Anyone, guys? Please give me an example. You can see this kind of thing in the real world, which we are using over the time. No idea? Anyone, guys?
So let's say Amazon or Flipkart, they're showing that. So what are the things you viewed? According to that, they'll give the next thing.
Bingo.
Spot
on. That's 100% correct answer. So
the user purchased on TV, then they'll be showing up might be a stabilizer or some sort of that.
Yes. So you are thinking that I got a big billion deal and I got 10% of the discount. I got best deal in the Amazon. I got the best deal in the Flipkart. Wrong. They are trapping you. Okay. So they are thinking that you got the best deal, but you are profiting them. Okay. So never buy or buy. Okay. So, but yeah, it's a spot on answer. So every time you go to the Amazon, you just browse a let's say washing machine. So you didn't purchase and come back. So Amazon will won't let you go. He'll throw you some offers. Okay, offers through the browser that 10% off is on this washing machine. If you purchase a washing machine, what you are going to see? You are going to see something like washing powder or something like that. Okay, this is what the data science is all about. So we read the human behavior, we read the human intentions, we read the human patterns, and we'll take out a pattern out of it, and we'll try to predict the future, what is going to happen in the next, right? So it is like astrology in the data or in the IT. That's why it has so many of market, because the company wants like, okay, what will happen of the finances of this company in next quarter. Who don't want to know their future? So we are going to give them what is going to happen to you, right? That's why it's a high pay, right? And it is a very rare skill to have. Now we'll talk about the data science more detailed. So going to deck, what is machine learning? The machine learning is the core of the data science, where we are going to train our machine so that machine is going to learn on the pattern or the behavior of your past data and is going to predict your future. Correct? Any doubts what is machine learning exactly? Anyone understood, or still you have some jitters of here and there? Clear, right?
Yeah, it's clear.
Okay, I need a thumbs up from everyone. Vishu, Yoganand, Sabrinath, 1+6, everyone, please give a thumb and be interactive. Guys, you are there or you slept away?
Yeah, it's clear.
Okay, cool, man. Okay.
Yeah, clear, Siddha.
Yeah, cool. So let me go for the data science life cycle. Okay, so just let me open that deck again.
Siddhant, one question.
Yeah, please.
So when it comes to data science and machine learning,
yeah,
where does AI stands, and how is the T structure? I mean, which comes first, and or the both are in the same pinch, or how is it? What is the hierarchical diagram, if I say?
Okay, so the hierarchical diagram, yeah, it is important question and good question. The first thing is comes into the picture is AI. Okay, it is called umbrella, right? It is an artificial intelligence, right? So in that artificial intelligence, we have something called machine learning. Not machine learning exactly. Data science or data science learning or data science. So we have another branch which is called blockchain. We have another branch is RPA. We have another branch is called robotics. Only robotics, mechanical. Or we have something we call mechatronics, or we have something called telematics. Okay, So inside the DS, we have something called machine learning, right? Inside the blockchain, we have some, some mining data algorithm. Inside RPA, we have something called bots. Inside robotics, we have again mechatronics, right? You got that hierarchy, right? First, it is coming
Yes.
as a AI, then it is a data science, then ML. So what consists of the data science? The data science consists of data visualization plus that data interpretation plus machine learning plus the output analysis.
Okay.
Okay, so the
Yeah.
whole all are called the data science. In order to do that, we have four type of analytics. So what is analytics? Can you tell me what is mean of analytics? Why it is not an analysis? Why it is analytics?
Maybe you analyze first and predict.
Sorry.
You use statistics to do some analysis.
Okay. So let me divide this word analytics is called analysis plus metrics. So what is analysis? To research on something, right? To analyze something. So what is metrics? Metrics is the measurement. Metrics is the measurement, right? So when we can measure our researches is called analytics. Okay, so we have four type of analytics. The first one is called diagnostic. The second one is called descriptive. The third one is called predictive. And fourth one is called prescriptive. So what is diagnostic? So when you let's say a hypothetical situation, you are sick and you are going to a doctor. What doctor does to you? It diagnoses, right? It sees the symptoms of what you are having right now. Means it queries the past. What is description? The description is like what exactly right now you are feeling. Okay, it is what happened in the past. What happened in the past. This is what is happening right now. So this is what is predictive. What will happen in the future. And what is prescriptive? The prescriptive is like the countermeasure of the future or the predictive. Got it? Any doubts, guys, over here?
No, clear.
Yeah. So now we'll go to the over here and we'll see the real-time process flow of the data science. What exactly happens in the data science? So the first step is like data source, from where I'm going to get the data. It can be a Facebook, it can be a web app, or it can be a a ERP like SAP or Dynamics or Salesforce or Marketo or Amazon or Teradata or Oracle, anything. The data source can be anything. So after that, so let's say a hypothetical situation, you are going to a shop. Okay, let's say it is a shop stop, right? You went to a shop stop. Now you purchased a watch. What exactly the shop stop represents gives to you? Guys, are you following me?
Yeah, your voice is breaking, Siddhant, in middle.
Okay. Is it clear now?
Now it's
Yeah. So if you are going to a shopper stop, what exactly the shopper stop represent gives to you? A bill, right?
yes.
So in that bill, what exactly it is mentioned? the purchase time, purchase date, amount, and everything, the details of your product, right?
Yes.
Yes.
Yeah. So where it gets saved, those data?
In the database, right?
In
Those-
the database. So that database is in that database, it got saved. So that database is called something called OLTP. So what is OLTP? Guys, full form of OLTP. Come on, we are all engineers.
Online transaction processing system.
Yes, online transaction platform. Okay. Okay. So let's say this is my transaction DB. So what exactly I will do? Can I do analytics over here? Can I do some analytics? No, I cannot, because it's very, very much frequent in nature. So it gets, updated very frequently. That's why I cannot perform anything on analytics. So what exactly I'm going to do? I'm going to push all my data to another DB, which is called OLAP, which is called OLAP, or which is called data warehouse, right? The process of sending OLTP database to OLAP database, what it is called, guys? No idea? It is called ETL, right? So what is ETL?
Extract, transform, loading.
Yes, extraction, transformation, and loading. So we extract from OLTP database, we transform the schema, and we load into the warehouse, which is OLAP. From there, I'm going to get my data. Let's say this is my OLAP, and in that OLAP or from the warehouse, I'm going to get the data and perform my model, or I'll apply that data science over here. Got it,
Yeah.
guys? Please tell me.
Yes.
Yeah. Okay. So what is data science exactly? To perform or do analytics. How many type of analytics? I have 4 type of analytics, right?
Yes.
Yeah. So the DS own itself is having a life cycle with it, right? So what exactly data science will do? We'll import the data from the OLAP. We'll import the data, then what exactly we are going to do? Visualize the data, then make some model which will give me the future value and deploy it. Got it, guys? Any doubts? What is the life cycle? Guys, any doubts?
So you'll be storing the model somewhere, or each time you'll be querying the OLAP and forming this model and all?
No, we'll be storing that models somewhere, so that what will happen, it will take a hell lot of time to process the first time, so that we'll store it somewhere. After that, it is going to encounter every time I'll update my OLAP, or I'll feed the data to my model.
So the first time it will take the whole data, then whatever the new things are coming up, it will pick up that.
Yes. And let's say from the last let's say a flower cell, so the last 10 years data says that he has to he is selling more flowers in the February 14, right? So it will
Okay.
learn on that. So whenever that date is you are going to feed, it will say how many or how much sale is going to happen on that particular day. You are getting my point?
Okay.
Yeah. So this is how it finds the pattern, it reads the human behavior, and makes a feature or the prediction out of it. So that's why the data science is a buzz in the market.
So the model will train automatically, or how is it going to happen? I mean,
Yes, that nice question. The model is not going to learn by itself. We have to make it learn, right? So there we are going to apply something called machine learning algorithms. machine learning algorithms. Okay, so we do have lots of type of machine learning algorithms. Let's say I have linear regression, the logistic regression, or decision trees, or support vector machines. These are the machine learning algorithm types. So each algorithm uh, does a specific work for me, right? There is a time series analysis. I'm going to future go where my time is a dependent factor for me, so I'm going to apply a time series analysis over there. If a continuous variable is dependent on me, then I'm going to apply a linear regression for it, right? So there are multiple machine learning algorithms are there to do a specific work for me.
Sir?
Okay.
Okay, any doubts?
Yes, sir.
Yeah, yeah.
Sir, what actually OLTP and OLAP are doing?
So OLTP is the DB which saves the transaction data. Okay, so when you go to a support shop and you purchase a watch, what exactly you did? You did a transaction over there, right? So those transaction data will will be saving in the OLTP. This is called online transaction platform, right? So I cannot do any type of analytics because OLTP is very much fluent to change. They gets updated with a fraction of second. So I cannot go with this kind of analytics on the OLTP. So what I have to do, I have to push all the data in a batch, and I'll keep it as a warehouse. I will keep in a data warehouse, which is called OLAP, which is online analytics platform. Okay,
Okay.
from there I can pull the data and process the data science life cycle on top of it, right? So you can see the same thing I did over there. So I went to the Walmart data warehouse. I took out 1 million of the data. I took it into the my work R system, and I have made it learn in the machines, and right now I can see the visualization process as a output, right? A small code, but it does a big things, right? So if I'm going to show another code which is in Python, so let me go and open Python for you to just show you what exactly we are dealing with. So any doubts, guys, as of now?
Now we are doing the batch processing on the OLTP. That's it, right?
Yes, yes. We'll do a batch process in OLTP to pull all the data to and push to the OLTP. Sorry, OLAP, right? So that batch process governs by the ETL.
Okay, but I have one doubt here.
Yeah.
You said that we are not going to get the fluent output if you're going to perform on the database. But
Yes.
uh, but the thing is, we can do some analytics, right? But
I didn't get it.
based on,
Come again?
we can do some analytics, whatever the data, whatever we have in the database.
Yes.
But the output is may not be that accurate.
Yeah. Output is not going to accurate, and the OLTP transaction databases are very much costly because it handles the real-time data, right? So if something goes here and there, it affects on the total transaction. So I will not take a risk. So that what I will do, I will keep it safe in an OLAP or warehouse. Then I am going to take a little bit of that data and I'm going to perform on it.
Okay.
Okay. So let me go ahead and I'll show you some cool things. But yeah. So let me go ahead and show you a, a
Sir,
yeah, tell me.
OLAP and OLTP are just for this situation, or in every situation it will be used like this?
In any situation we can use the like this, but as of web application, those are the intermediate steps and we don't bother about it. The data science don't bother about how the data came into the data warehouse. We bother, okay, the data is inside the warehouse or not. Okay, once it is inside of the warehouse, I'm going to take the data and do all the stuff over there. Okay,
Okay.
got it?
Got it.
Yeah, let's say in a small artificial intelligence image or program over here. So let me just open a small data set which has a face values. Okay, the face of a person. Okay, so this is a face of a person. So let me take this face as a data, and what I'm going to do, I'm going to cut it half over here. Okay, in the between, from the below nose to chin, up to chin. So I'll cut down, and I'm going to make my machine to learn, so that it is going to build my other half of that human face, right? So where exactly it is uses, in US, they have a program in the CIA. CIA, what is CIA? US CIA. It is like
Simple,
CBI in the India. Okay,
yeah, simple investigation.
yeah. So they have CCTV camera footages of the terrorists. So the terrorist, the face of the terrorist is not that much of visible, but they identified, okay, that is the guy, but they are only able to see half of that person. So how to predict the other half, right? So in an angle, you can imagine there is a less angle in the face, so that you cannot imagine or you cannot create that face by itself. So what you are going to do, you are feed that image to this model, and it is going to create the entire face for me. Okay, so it is a cool application, which this is my code actually. So you can build it like this way. So if I'll execute, so I have only 100 line to show it. So you can it will take some time, and it will create a few faces for me. Yeah, but this is how data science works. So it predicts the the other half of that particular person's face by reading different faces or different structure previously. Got it?
Yes.
Any doubts, guys?
So Siddhant, for this example you showed it. What is the input you're passing to this one to predict the other other half, right?
The other half is like, I'll be processing a lots of face image data, so that what will
Mhm.
happen, it will take different faces, and it tries to learn if the upper half is like this, what is the lower half. It tries to learn that pattern. Got my point?
Okay.
Okay, so if I'll give you your image as a half, it will learn first what is the upper half of yours, and based on that, it is going to build the other half or the lower half of your face by itself. Got it?
Okay. Yeah, got it.
Yeah. So we have source over here. So the source is like transaction platforms like OLTP DBs and file system DBs, which Facebook, YouTube, and Twitter uses. So after ETL process, I'm moving the whole data to the OLAP, and in OLAP I can do perform a BI. So what is BI?
Yeah, business intelligence.
Yeah, business intelligence. So I can perform the BI, or if the OLAP is getting bigger and bigger, I can use a distributed environment, which is big data or Hadoop. I can always use that Hadoop as a part of the storage space, and as a big data analytics. So I can use Hadoop or Hortonworks or anything with a distributed file system. Then I'm going to pull all the data to my workspace, that is R and Python, and I'm going to analytics. I'm going to perform analytics on top, and on top of it means I'm going to perform a machine learning algorithm. Then I'm going to create a model, and which the model is going to deploy. Okay, so deploy is like it. Let's say the model is deployed on the Amazon web server, so that whenever I goes to the Amazon, and I tries to browse a washing machine, it gives me a instant discount or a suggestion whether you like this one or that one. So that is called a deployment. Got it? So guys, any doubts up to now?
So, do we need to learn big data also to come into that because it's in the
Yeah,
middle?
we have to learn 3 or 4 components. Like we are going to learn HDFS, we are going to learn Hive, we are going to learn Scoop, and the most important is we are going to learn the Spark component. Okay, so 4 components we are going to learn, and the most important part is Spark. So we are going to learn Spark a little in depth. Okay.
Okay.
Guys, any doubts from anyone else? Come on, guys, be a sport and ask something.
Sir, in previous example,
Yeah,
uh, uh, you told that it will be learning from the images we will give.
yeah,
So, sir, we will give full face images or half face images, or we will
yeah.
give half and half face images.
So we'll be giving a full faces to make them understand, right? So let it execute, and I will show you exactly what is input. So we'll be giving the full faces only, so that it goes of the upper half of that face, and it tries to learn the lower half of the face, right?
Yes.
So
Okay, sir.
in order to make my machine learn, I have to provide the full face to my machine, right? And the machine is going to make it half, and it is taking the upper half, tries to find the patterns, and it learns on the lower half, right?
Yes.
So here you can see over here the output. Okay, it got it is my true face which I provided to my machine, and the machine took a half of it, the first half, and that it tries to predict the lower half of like this, so which is not correct, right? Which is not correct, right? Entirely. Yeah.
Yes.
But these are the machine learning algorithms. So if I'll process the true face with the extra tree algorithm, so it is going to give me a prediction like this. So if I'm going to give an image, it is going to say like the total image should be like this, so which is not little bit of correct, but you can see it is going to be a 60% similar to what we have in the true faces, right? So it is called a KNN, which is K nearest neighbor, again a machine learning algorithm. So we have random forest regressor, again algorithm. So you can see the machine is generating the faces, right? So it is a sample of the faces, it is generating the in the first face you can say like, okay, the face is little of down, and here the little up, and it is smiling like over here, and it is smiling like hell. Okay, you can see these things, and the machine is trying to learn what exactly the person is going to do with the facial expression, and how to build a total face out of it. Got my point?
Yes, sir. From where is the computer is taking the images, like
Yeah,
images?
yeah, we have a data set over here I have mentioned, which is called Olivetti faces. Okay, so Olivetti faces, as the extension is NumPy. So we'll be giving that image as a pixels. Okay, we are not giving the image as a JPG, but we'll be giving that entire image as a numbers, so that it is going to understand if it is a 2 and it is a 4. Okay, so he understood if it is a 2 it is going to be 4 for every other faces, like that, right? Got it, guys? In doubt?
Yes.
Yes, no, maybe.
Yes, continue.
Okay, so I think I have covered the entire real-time process, exactly what is happening in the data science. We have ETL tools like SSIS, like SQL Server Integration Services, Ab Initio, OBIEE, but we are not going to bother about the ETL tools. I'm just letting you know because we have the ETL tools, and we are not going to learn any ETL, coding or something like that. We are here to learn about only data science. So we have something, Hadoop components, HDFS, MapReduce, Spark, Hive, HBase. So these, first four we are going to learn in depth. Okay. After that, we have something called deployments. So the deployment can be R server, can be Amazon Web Server, or can be Azure ML Studio. Okay, the deployments we can do over here. The key takeaways of the total entire course is like, first we are going to learn the maths, and after that we are going to learn the statistics. Then we are going to learn a language called R language. Then we are going to learn another language called Python. Then we are going to learn a little bit of statistical knowledge, okay, the applied statistics. Then we are going to learn about the machine learning algorithms like weak learners, ensembles, and deep learners, AI algorithms. Okay, we are going to learn all about those things. Then we are going to learn about natural language processing. So natural language processing is like all about the chatbots. What is chatbot, guys? Any idea?
Yeah, yes, Siddham.
Yeah. Anyone else? What is chatbot? A machine is going to respond to your queries or is going to talk with you. It's basically a robot. Okay, nothing else. So we are going to learn something, that Hadoop components in the big data, and we are going to learn something AWS and Azure as well. And we are going to see for the real-time projects for every algorithm and their, usability. So how to use those algorithms and which way we can go and put through a real-time system. Okay. So guys, any questions? I think I covered everything over here. All
Siddham, I
clear?
have one now.
Yeah, tell me.
Siddham, yeah, you explained one example right just
Yeah,
now regarding the image, face images.
yeah, yeah, yeah.
Generally, when we are going to train a logistic regression model, you're going to specify like a 70-30, 80-20 like that. You're going to specify the training and test data. Yeah.
Yes.
So here, how do you know how much of data we're going to train to that model? Like these many number of photos or how faces we need to give the input as a model. How do we know that number of files? That one.
So it depends on your business requirement, Hari, was purely. But over here, I have the training data set with me as well as the testing data set with me, right? So other guys, what is train data set and test data set? Please don't bother about it. We are going to learn. So he asked a question. I think he knows a little bit. That's why. So let me clear to him. Otherwise, the train data set, what is test data set? We are going to talk about very briefly in the coming sessions. So it is already I have a test data set, so that I am not doing any split over here, data split over here. Okay.
Okay.
So guys, any doubts regarding this session? No guys? All good?
So, Siddhant,
Yeah.
yeah. So when will you come to know that your model is mature enough and you'll stop training it, or
Yes.
it is a continuous process?
Yeah. We have some statistical learning so that data visualization comes into the picture. We are going to see what is overfit, what is underfit. What is overfit means the machine is trained enough. I don't want to go ahead and train that, right? So that scenario is called overfit. Okay. So we have to learn what is overfit, and we can see those things by statistically, by coding itself also. And there is some situation that machine doesn't understand anything as of now, so that is called underfit, right? So we have situations like that.
Okay.
Okay, so there will be a little statistic involved. We'll talk about the statistics and math rigorously in the coming sessions. Okay, so let's park this question for later session.
Sure.
Any doubts as of now?
Siddhant, which language we are going to work on? I mean, in the sense, while learning each algorithm, so which language will go with R or Python?
So actually we are going to learn by both. Actually I work on Python. Okay. So but here
Okay.
we are going to learn R and Python. Okay. And the true fact is R is covering like 10% of the market, whereas the Python covers like 85% of the market, and rest 5% goes with the Scala and Julia and everything. Okay, any doubts? Anything else? Please
Hi,
guys.
Siddhant.
Yeah.
So are we developing the algorithms or are we using the algorithms which are already developed?
We are using the algorithms. Okay. So
Okay,
to
yeah.
develop the algorithms, we need some patent. Okay. And to file a patent, I require 3 lakhs of rupees and IEEE recommendation so that I can, develop an algorithm. But jokes
So all
apart,
these algorithms are all
yeah, it's all the algorithms is already defined and we are going to apply them.
okay.
Okay.
Okay, yeah.
Yeah.
So just to add to what Siddhant was just saying, I mean these algorithms, so these algorithms have already been defined, okay, based on my requirement and usage as to what type of model we have to apply. Is it am I going to make a Boolean prediction? Am I going to predict a continuous value? Based on that, we'll pick up a regression or a classification model and then deploy it. So sorry, having said that, so whenever you're choosing a model, you have to be very well aware of the output of the model. Okay, so you just cannot go ahead and predict, right? That let's say my age corresponding to a height will be 34. So you have to understand what are the output of the output of the model in terms of the statistical values which the model throws. So these are already being set. I mean, we know that there's certain parameter p-value for a model. Let's say you have something called accuracy. So all those understanding has to be there so that once someone asks you what exactly is your model doing, you should be in a position to answer, right? So that was just a point here. So I think we've pretty much covered the demo for today, and I very well understand that this is too much of information to understand and digest at one shot. But this is extremely intriguing and exciting, and that's why once someone who's actually working on it starts talking about it, there's no end to it. Anyway, there are a few other things which I wanted to talk about before we kind of wrap up the session for today. So this is an online batch here, and this is an online batch here, and we do have, I think we'll have classes from Monday to Friday, and that would be from 10 to 12. Okay.
Hello.
Yeah.
Yeah,
Am
we
I
are not
audible?
able to hear you.
Can you hear me now? Can you hear me now? Am I audible now? Hello? Hello? Am I audible now?
Yes.
Okay, awesome. So there are a few things I wanted to talk about, uh, you know, about the session and the approach we should follow. So there are, we as a group, we have multiple trainers with expertise in various domains. So I think Siddhant must have talked about so a concept about weak learners, and then how we get into ensembles, and then we get into the neural network. So uh, as a team, what we have done is we've divided the team into various lines, and these lines basically deal with expertise in each of these areas. For example, I come from a background where I have expertise in the weak learners, and I talk about all the models in that area. Dan is an expert when it comes to neural networks. Then we have a couple of other trainers who teach ensembles. So, but before this, so we have mathematical classes as well, and we follow both. We follow two options. One is the weekday and the weekend. But for this batch, I think we'll have to follow the week option, where we'll be covering classes every day from 10 to 12 in the night. I mean, I'm not saying that every day is going to stretch till 12, 12:30. There'll be few days where it wraps up by 11:30 or 11, but there are a few days where it could stretch up to 12:30, depending upon the discussion. So the data science again is a two-way conversation. It gets bigger. I mean, it gets deeper and more detailed once conversation starts flowing from both the sides, right? Once the idea flow starts from both the sides, that's when the you start learning. So for this session, we'll be following weekday options, that is 10 to 2, and we do have options for remedial classes for the weekends. So that should not be a problem. I mean, that again is on a need basis. And the entire length of the duration of the whole training would be for about 3 months. That is the maximum we're giving right now, considering various factors, because you have Christmas coming up, you have New Year, so you might have to kind of disconnect for about a week so that everyone else gets a good vacation. But again, sorry, I have a bad throat. Uh, the duration of the program should be close to 2.5 months or three, if I may say, and the total fees would be 40,000. So, I mean, it might come as a shock to you at this point of time, but to be very frank enough, if you kind of go to the market and get into various data science institutes in all the metros, you understand the fees they are charging, and then probably you will realize what is the content we are delivering and in what price, and what is the content they are delivering in that price. Now, it's fairly possible that you might think that if the institute is charging high, it could be because of the quality content. But both Siddhant and I have been personally involved in training at all these professional institutes, and we do know what is the quality and what is the level of expectation of those. So since we started something on our own, and we want to make sure that whatever we have gets into others as smooth as possible. So that's why this whole initiative. So that was pretty much from the length, from the fees, and what else? The options which we have for the classes. So if you guys have any questions, I mean, if you want to take it offline, if you want to discuss it with Siddhant or discuss it with me, that's absolutely fine with us. So if you want to talk to me, you can just ping Siddhant. I hope you guys have his number. If you don't, just let me know in the chat window. I'll ping it. I'll ping my number as Siddhant's number. That should not be a problem. Okay, that's pretty much from the management side of it. If you guys have anything, feel free to ask the right moment, or we can call off the day.
So one quick question.
Uh-huh.
Yeah. So when it comes to SMSC, I mean, whenever we'll read or anything, everyone will give up the same thing. What is Amazon is doing? What is Netflix is doing? So there are what I 15 companies which we know which implement all these things. And what about the job? I mean, the small scale industries. Is those people that really working on it, or how is this industry?
So
The probability. I mean.
yeah, actually, there are different business cases. Let's talk about the Amazon. So he, have something, a method called appropriate method or appropriate algorithm, which is based on the Bayes theorem, joint probability or condition probability. Okay, the same thing happened and mimicked by some of the organizations, right? So the small scale organizations, they are also looking for some business analytics from the big firm. So let's say I'm working for a Verizon, and or I am working for Wells Fargo. I work for Wells Fargo as well. So the Wells Fargo, what exactly it says, I got the data, and I have to analyze whether a person is going to pay their loan or not. Correct. So the same thing or same algorithm, Wells Fargo has implemented it. The same algo that JPMC also, JP Morgan Bank also implemented it in around the corner, or around the all the business criteria with banks. So the small firms, they got the chances like, okay, request, you go for the risk analysis, you go for the payment intent analysis. So they are working on different criterias or the conditions, right? So they work on the same formula or same algorithm, but for a different cause. Got my point?
Okay.
Okay, the algorithm is going to remain same. Okay, the implementation of the algorithm based on the data set what we are having, or what we are working right now.
So it is still a POC, or I mean, really people are doing it?
Yeah, I'm doing it.
No,
Okay.
it's not a POC. For example, you have stock markets, right? So firms from the financial services industry, they do it on a real-time basis. I mean, you read today's data and then predict for tomorrow's stock. This is one example from financial. When Siddharth was talking about how do you analyze if a defaulter is going to pay or not. So these are real-time examples of people who are doing it. And I'm not sure if Siddharth covered this point, but so this is one of the examples which you have picked up. And there were various few other examples as well, which we have kind of included in the curriculum of this training, so that people, sorry, people who are coming from different backgrounds have a real-time understanding of what's actually going around in the industry and the market, so that once they get inside the job, they are pretty much aware of what's actually going on. They're up to speed of what's around them.
So right now I'm working for Verizon, and my day-to-day job is to predict whether a person is going to pay their telephone bill or not. I have to predict it. Okay. So day by day it gets refined and refined and refined. So that's what exactly I do. Okay.
Okay.
So any more questions, guys? Anything?
No, Siddharth.
Okay.
Yeah, good.
So let's call it a day and wrap the things up. And let me know, that tomorrow the same timings the meeting is going to start. Okay. And from tomorrow I'm going to start with the basic mathematics, that is coordinate geometry and triangles. Okay. And a little bit of trigonometry. So if you are interested, please let me know and join the sessions. Okay.
Sure.
Yeah. Thank you, guys.
Awesome,
Thanks
guys.
all.
Nice talking to you, everyone.
Thank you.
Thanks.